we want a graph x equals y squared. First of all, how's this guy open?
To the right.
He opens to the right. Now, if I want to think about his vertex, x is going to be equal to 2 times y minus 0 squared plus 0. Technically speaking, in standard form, that's what that is. Which means that hk, h, this is h, this is k, hk is 0, 0. Acts as a symmetry because he opens to the right is y equals 0. And x-intercepts, if they exist, it still works the same way. X-intercepts, where the graph crosses the x-axis, that means y is 0. So 0 equals 2 times 0 at x equals 2 times 0 squared, x equals 0. So it's 0, 0. Y-intercept is where it intersects the y-axis. That means x is 0. Or we get that 0 equals 2y squared. Y squared equals 0. Or y is also 0. So I have one coordinate point, 0, 0. And if you think about it, I know I can do a quickie sketch. I know that he opens to the right. But in order for me to be able to get a sketch of him up, I need one more coordinate point. Now, I can pick any x value because the thing that I do know, I know that x is 2y squared. So I can pick any x value, but I think about it. If I put an x equal 1, I'm going to have 1 equals 2y squared, y squared equals a half. I'm going to have to deal with radicals, right? Square root of a half. If I put in 2, that might not be too bad. If I put in 2, because the coefficient here is 2, so I choose x equal 2, I get the 2 equals 2y squared. Y squared equals 2 divided by 2 is 1. Square root both sides. Don't forget the plus or minus. So y equals plus or minus 1. So that says if x equals 2, y equals plus or minus 1, y equals plus 1 or minus 1. Now that's going to give me the rest of the information I need to know. If x equals 2, y equals 1, and then y equals negative 1, and then that's all I need in order to actually get him up. So if I'm graphing these things, what I normally do is once I get the x and y intercepts, I put everything I know on there, and then I say to myself, and I know the direction it goes, so I had a little sketch in there. So it says, what do I need to get the graph up? Well, in this particular instance, I only had one coordinate point. I sketched it, so I know it goes this direction. I need a coordinate point that's going to give me 2 more points. And then I choose judiciously so that I would not have to have fractions or radicals that I have to evaluate.
Do I have to start off with choosing something for x, or do I choose something for y?
You could choose something for y, but if you choose something for y, what happens is you'll get an x value, then you have to choose another one.
Y, yeah.
Then you choose another y value, and then you get another x value, and then at that point, you'd still have 2 points. It's a longer process, but it works. Yeah. That's why sometimes a picture kind of helps, and it says, well, I could choose y values and get out x values, and absolutely,
I
yeah.
just plug in one
Yeah.
data, one for y, real
And you get to the same place. Now, here's another one, and you can figure our focus is going to be left and right because we spent so much time on up and down. Because left and right is the new concept. So how does this guy open? Left. And he opens left. That's because A, which is this guy right there, is negative. Now, if I take a look at this, this is 1 and 2. This is H. This is K. So it's still X comma Y. So the vertex is not YX, it's XY. So that says H is 2 and K is 1. So the vertex is at 2, 1. The axis of symmetry is going to run horizontal. So that means it picks up the y coordinate of the vertex, so it's y equal 1. So I'm going to put in what I have so far. I've got a vertex of x equals 2, y equals 1. There's the vertex. The thing that I do know is that he's going to open left, so I can put a little shadow in there that knows that he's going to open left. And that says if I can get essentially a point on either side, because here's your axis of symmetry right here.
Why is that positive 1 and not negative 1?
Because that's your transformation, remember?
Okay.
Yeah. If that were a +1 in there, a y + 1, then it would be -1. That's a good old transformations again. So I'm going to go after first the x-intercepts. And the x-intercept is where y equals 0. So that would say that x equals -3 times 0 minus 1 squared plus 2, which is -3 times -1 squared plus 2, which is -3 times 1 plus 2, which is -3 plus 2, or -1. So that says I have I need to move this out of the way, then move this up. I have an x-intercept at x equal -1 and y equals 0. So right here. Now at this point, if I wanted to, I could use symmetry to finish the graph, because it's symmetric across the axis of symmetry. This says that x equals 0. These guys can be a real pain in the rear, by the way. So what this is going to tell me is that 0 equals -3 times y minus 1 squared plus 2. So now I need to solve for y. And in order to do that, I need to subtract 2 from both sides. So -2 equals -3 times y minus 1 squared. Divide by -3. Y minus 1 squared equals 2/3. See, these are unpleasant. So now we get to take the square root of both sides. Don't forget the plus or minus. So that y minus 1 equals plus or minus the square root of 2/3. And then I'm going to pull my handy dandy little calculator, because we need numbers. So I'm just going to go ahead and do the square root of 2/3 and be done with it. So, clear. The square root of 2 divided 3 is 0.8. That's sufficient. Or that y equals 1 plus or minus 0.8. So what do we have? We have y equals 1 plus 0.8, which is 1.8. Y equals 1 minus 0.8, which is 0.2. Boy, that's not friendly, is it? So, that says if x equals 0, y equals 1.8, and if x equals 0, y equals 0.2, and now you might notice something. I have a coordinate point in the wrong place. What do you see? What did I do?
Did 0, -1, 0, -1.
Yeah, I did 0, -1, it did -1, 0, so out comes the white tape. White tape, and it should have been -1, 0. So now this makes sense with these two y-intercepts. 1.8, which is about right there, and 0.2, which is about right there, and then the best we can. He's very narrow. Why do you think he's very narrow? -3. Yeah, you've got a horizontal stretch, because now we're working on, everything's opposite, right? You've got a horizontal stretch, -3, because -3 is on the outside, and we're dealing with y's. So if that's the case, that parabola is going to be narrower. Not much fun.